Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use Cartesian graphs of a radius against a theta to help with drawing a polar graph. So what we're going to do here, and this is number 12 in the current textbook I'm using to teach Calculus 2 here, we're going to try to sketch a plot here of r squared equals minus cosine theta. Now again, we're going to try to sketch a polar plot of this. Before we do, however, I'm going to start by just doing a plot of r squared against theta. The idea is I'm then going to use this plot to graph r against theta, which I will then use to make my polar plot of r against theta. Now, let's focus on this minus cosine theta. And before I even focus on the minus sign, I'm just going to focus on this. Cosine theta would look like this. Cosine theta would go through the point 0, 1, pi over 2, 0, etc. This is minus cosine theta. What that's going to do is flip this thing upside down, or reflect it about the x-axis. So I'm going to start with that graph. Minus cosine theta is looking something like this. Now, some important points here. That guy right there is pi over 2. So this is 0, this one right here, that's pi, 3 pi over 2, and that very last one right there, theta is 2 pi. Now, that's a graph of this animal right here. And it's important to realize that r is a distance, it's positive. So r squared equals minus cosine theta is not defined in this region or this region. We're only going to get a graph where r squared is positive. So I'm going to go back to my graph here and just kind of throw that out, because r squared has to give a positive value. Right, now, next, our graph of r against theta. And when we go from here to here, this step, there's an important thing to realize. When we solve an equation like x squared equals 4, this has two solutions to it. X could be positive 2, or x could be negative 2. Any equation kind of in this form, something squared equals a number, is going to have two solutions, a plus and a minus. So, when we draw our graph, get rid of that there, don't need this anymore, of r against theta, right? This pi over 2, 0 is there. This 3 pi over 2, 0. There's one positive solution, which is going to give us a sketch something like this, but there's also a negative solution for r, which is going to give us something like that. So again, this step, this has two parts to it because r squared equals some number has two solutions, one value greater than 0 and one value less than 0. This would still be the point pi 1. This would be the point pi minus 1. Now what we'll do is we're going to use this graph to sketch r against theta up here in polar coordinates. So, you'll notice here that we're starting, let's see, at pi over 2, because there's no values for this function before then. At pi over 2, this thing's got a value of 0. I'm getting that from this point on the graph. Now, I'm going to kind of think of this in two different ways here. One, I'm just going to think about, for now, just kind of the top half of this. So if we're starting at pi over 2 and we're going to pi, over here that's in quadrant 2. Pi over 2 to pi would be that angle, change in angle right there. The radius is going from 0 to 1. So this is going to do something like this. See how the radius, again, is starts at 0 and is increasing, going to 1. This would be the point let's see, what would that be? That'd be the point pi, whoops. This textbook always does the distances first, 1 pi. I'm used to doing the angle first, but. Now, let's talk about the negative values for r. Again, when we're in the pi over 2 to pi range on our graph, that's in quadrant 2. The positive value for r is filling out radii here that are in quadrant 2. The negative values for r, which are these, and I'm going to go ahead and just do those in green, these are going to fill out values over in quadrant 4. Okay. The radii is starting at 0, going to -1, so starting at 0, and again, going to -1 is going to put us over here. So we're looking something like this. Okay. So at this point, this left-hand side of this graph is mapped out with both the positive values for r and the negative values for r. So it's important to realize, I'm going to color code this in orange, this part of the curve is giving us this in our polar graph. And this part of the curve is giving us this part of our polar graph. All right, now, as we go from pi to 3 pi over 2, now again, in our polar graph, pi is basically that angle. 3 pi over 2 is to here. So this next part of the curve, the positive values for r are giving us distances that are in quadrant 3, or giving us points in quadrant 3. So these values here, the radius starts at 1, goes to 0. Right. Here we are, starting at 1, radius going to 0. And again, that means these distances getting smaller and smaller and smaller, going to 0. The negative part of the curve, right, the negative values for r are filling out points over in quadrant 1, right, because our angle is quadrant 3. If we're between pi and 3 pi over 2, that would put us in quadrant 3. Then these negative values for r are actually filling out points over in quadrant 1. And those radii are starting at -1 going to 0. So this point right there is this point on the graph. Right, again, pi -1, so angle of pi, and then -1 would put us over here. And then the radius going to 0. So over here what that's doing is something like this. And again, you notice the radius getting smaller and smaller and smaller, going to 0. And there's our graph. I'm going to go ahead and sketch it in one solid color now. I like this kind of purple color. So there's a graph of r squared equals minus cosine theta, give or take. Now, it's just a rough sketch. That's all it's intended to be. It's not intended to be a perfect graph. The intent here is how to start with an r squared graph, use it to graph r against theta. Again, Cartesian, that's standard left, right, up, down. And then use our r graph here to do our r against theta in polar. So I hope this video helps do those things. Have a great day.